Well, good evening. Figured I'd give you a bonus update. We've had storms fire. Got a little pair of isolated cells that developed between Memphis and Childress earlier, and then they moved on off to the east, and we had the storm split. There's the left mover, and then the right mover is located right there. And if I animate that, you can see how they progressed. So definitely some different motion between the two cells. And there's a look from the Frederick radar. They do look kind of like straggly cells there. There is some rotation on this right mover here. And we got to keep in mind the radar is right there, so we're intercepting it like that. And this is showing cyclonic convergence. Yeah, this part here is 44 out. This part is 37 knots in. So we got about 70 knots of rotation, but that's spread across about 4 miles. So that's broad rotation. And the center of the rotation is about right there. And that's going to be in that little notch right there. And if I drag the cursor through that notch from northwest to southeast, you can see the overhang. That's all the updraft. And aloft, some pretty good hail up there, 20 to 25,000 feet. So the progression of the satellite loop shows the development there between Memphis and Childress, and then the storm's pushing on off to the east. It looks like some other activity developing down the dry line. See that storm's pretty much near Dickens and Guthrie. One little cell there. Now keep in mind that these are all going to be kind of high based. We saw on the skew-ts the moisture was problematic. Texas Tech Mesonet plot shows the dry line about right there, and it's broken up by a outflow field. Let me see if I can draw that outflow. That looks to be an outflow pool right there, and if we go further north, then we hit the frontal boundary right there. So you see how there's that outflow from the storms that were out there over the Childress area. And then back behind it, we got the dry line air. Well, that's a terrible color. Yeah, let's try yellow. That's the dry line air moving in, and you can see the lower dew points with lots of 20s. So that has pretty much wiped out the triple point area, and any favored area for new development would probably be back west of Childress, right about there in that triple point, although it is starting to get a little bit late in the convective day. So we're not going to get very much help from heating. Does look like there are a few towers trying to go up in that area, but I'm not too sure they're going to make it. So we're probably dependent on these two cells, especially the right mover, for any severe weather until that squall line starts coming together up to the north. And this shows that the squall line development is going to be an after dark event. HRR is not picking up too well on that cell near Childress. You can see it tries to develop it around 1Z. That's already happened. However, yeah, the MCS up there, that comes together about 9 to 10 p.m., and we can see how that progresses quickly to the southeast through Oklahoma City about 1 a.m. and just pushes into the Texarkana area down to Paris. This temperature plot shows the development of the cold pool, and we go forward an hour, and you can see how fast it moves, jumping ahead 50 to 60 miles an hour in 1 hour. So I would expect, depending on whether this pans out, there could be a corridor of some wind damage from Norman down to McAllister and north of Durant, Ada. So we'll see how that goes. And then things start fizzling out as we get towards 4 to 5 a.m. And then you can see the front itself making progress southward and sweeps down into South Texas for tomorrow. So here's an update on our cell there along US 287 and the Quanah area. This storm is rotating, but as I mentioned, it is going to be high-based. The velocity field looks like this. Not a whole lot of rotation, but we've seen some transient features on the backside, and if I run this back, You can see what, actually I need to drop down to 0.5. Let me try that one more time. But if we run the velocity back, you can see what looks like a interesting little, very, very small scale feature. That would be, let's see, about 1 mile west of the town of Quanah. So I'll be interested to, I would be curious to see what chasers saw right there, because if I set that mark there, let me zoom out a bit, you can see that's on the backside of the storm. However, looking at the higher tilts, it does correspond to something there. Just a very small scale feature. I'm not sure what that is. I'd be very curious to see what the ground observations and chaser videos might have seen in that region. So anyway, yeah, the storm is rotating, and one last look at the models. This is the European model. I did find it kind of remarkable how the European model pretty much nailed this cell, whereas none of the high-resolution rapid refresh runs captured that very well. Just, you know, this gave us a little pop up there around Altus around dusk, and that was it. There's the Nissel WRF. Yeah, it did pretty good. That's 7 p.m. A little bit late on that initiation. There's 8 p.m. But it definitely was in the ballpark. And then let's see. And as we mentioned earlier, the HRW, ARW generated nothing. So anyway, that's the way things look. I'm going to go ahead and get this uploaded. Thanks for watching, and we will see you tomorrow. Bye-bye.